Hello guys, welcoming you all. Today we are going to see about atomic and molecular spectroscopy. Unit 2, Raman spectroscopy. Raman spectroscopy. Raman spectroscopy is a non-destructive chemical analysis technique which provides detailed information about chemical structure, phase and polymorphy, crystallinity and molecular interactions. It is based upon the interaction of light with chemical bonds within a material. Diagram shows that the Rayleigh scattering, Raman scattering. Raman is a light scattering technique where a molecule scatters incident light from a high intensity laser light source. Most of the scattered light is at same wavelength as the laser source and does not provide useful information. This is called Rayleigh scattering. However, a small amount of light, typically 0.000001% is scattered at different wavelengths or colors which depends on the chemical structure of the analyte. This is called Raman scatter. A Raman spectrum features a number of peaks showing the intensity and wavelength position of Raman scattered light. Each peak corresponds to a specific molecular bond vibrations, including individual bonds such as carbon to carbon, carbon double bond carbon, nitrogen to oxygen, carbon bond hydrogen, etc. and group of bonds such as benzene ring, breathing mode, polymer chain vibration, lattice modes, etc. The diagram shows that the wavelength and wave number information provided by Raman spectroscopy. Raman spectroscopy probes the chemical structure of a material and provides information about chemical structure and identity, phase and polymorphism, intrinsic short strain, contamination and impurity. Typically, a Raman spectrum is a distinct chemical fingerprint for a particular molecule or material. Can be used to very quickly identify the material or distinguish it from others. Raman spectral libraries are often used for identification of a material based on its Raman spectrum. Libraries containing thousands of spectra are rapidly searched to find a match with spectrum of the analyze. In combination with mapping Raman system, it is possible to generate images based on the sample's Raman spectrum. These images shows distribution of individual chemical components, polymorphs and phases, and variation in crystallinity. Raman spectrum is both qualitative and quantitative. The general profile, peak position and relative peak intensity provides a unique chemical fingerprint which can be used to identify a material and distinguish it from others. Often the actual spectrum is quite complex, so comprehensive Raman spectral library can be searched to find a match and thus provide a chemical identification. The intensity of a spectrum is directly proportional to concentration. Typically, a calibration procedure will be used to determine the relationship between peak intensity and concentration, and then routine measurements can be made to analyze for concentration with mixed. Relative peak intensities provide information about the relative concentration of the components, while absolute peak intensity can be used for absolute concentration information. Raman is used for microscopic analysis. Raman spectroscopy can be used for microscopic analysis with a spatial resolution of order of 0.5 to 1 micrometer. Such analysis is possible using a Raman microscope. A Raman microscope couples a Raman spectrometer to a standard optical microscope, allowing high magnification visualization of sample and Raman analysis with a microscopic laser spot. Raman microanalysis is easy. Simple, place the sample under the microscope, focus and make a measurement. A true confocal Raman microscope can be used for analysis of micron sized particles or volumes. It can even be used for the analysis of different layers in a multi-layered sample and a contaminants and future beneath the surface of transparent sample. Motorized mapping stages allow Raman spectral images to be generated, which contain many thousands of Raman spectra acquired from different positions on the sample. False color image can be created based on the Raman spectrum. This shows the distribution of individual chemical components and variation in other effects such as phase polymorphism, testosterone, and crystallinity. Thanking you.